Welcome to this video. So in this video, we will go over this exercise, which is asking us to use Panda's multi-level indexing or hierarchical indexing to do some data processing and data aggregation operations. This exercise is using again the same dataset from Gapminder, which has country demographics including population, life expectancy, and GDP per capita over different countries in different years in different continents. So the first question is asking us to reorganize the data. So we have a table which has countries on the rows and columns are the year, and the values are the country population in that year. So this is a data shaping or a data reorganization exercise. And it's asking us to benefit from the fact that we have two axes, rows and columns, and put years in the cells at the intersection of the row, country, and column year. So if we look at how the original data is formatted, the original data is formatted by listing the country and the year and the population data in one row. This format is called the long format because if you have one country and multiple years, there are going to be multiple rows in the data frame. Instead, if we only have two attributes like country and year, three attributes, country, year, and population, we can use a different format called the wide format, in which one of the attributes go over the row index, the other one goes over the column index, and then the value of the third attribute will be in the cell. So this data organization exercise is interesting because while it may not be necessary for data transformation and aggregation, it's handy to know how to convert data for presentation purposes. All right, so let's take a look at this question. It's asking us to reorganize the data, and the first hint we're getting here is the name of the columns that we need to have in the new data frame. So those are the country, year, and population. So in the first step, I'm going just to keep these three columns so that I don't need to be confused by the existence of the remaining columns. So I'm going just to select data, country, year, and population from data. So that's fancy indexing, and we get a slice of that data frame containing these columns here. All right, so now it's asking us to assign the rows to be country and the columns to be year. So we know how to change the index of the data. We can call on the function setIndex and pass in country as a parameter. And here we get a new index, which is the country here. Now it's possible to rearrange the columns index of our data frame, but we haven't looked at how to do that using the built-in pandas operations. So what we're going to do here, we're going to use the row index and benefit from the fact that pandas allow us to unstack rows to columns to rearrange the format of the data. So instead of setting the index to be country, I'm going to set the index to be country and year in this case. And you can see that what we get here, we get each country over different years and then the population. What's important to note in here, I'm going to store this in a temporary variable called df. What's important to note here that if you look at the index of df, it's this multi-level index which contains two pieces of information, the country and the year. If we look at the columns, it will be only the index. Column contains one value, which is population, because now we only have one attribute, which is population. All right, so now with this multi-level index data frame, what I'm going to do, I'm going to unstack one of these indices, one of these levels of the index on the other axis. Right, so the other axis now contains only population. It's possible to unstack this value over population. So the function is called unstack, and I'm going to pass the name of the level of the index that I want to unstack. So in this case, I want to unstack here. And what we get here, we get a two-dimensional data frame in which we have the index over rows to be the country, and the index over columns to be population and year. Okay, so this is worthy of kind of a more detailed view. I'm going to store it again in a temporary variable, df2. If we take a look at the index of df2, it's no longer a multi-index. It's now an index containing countries. Why? Because we unstacked one of its levels to the other axis. If we take a look at the columns now, columns of that data frame, we can see that it's now a multi-index. It contains the population in each one of the years. So the unstack operation effectively kind of exchanged that second level from being a second level on the index of the rows to being a second level on the index of the columns. Again, the benefit here is that the data is now organized in a wide format. That's the same information, but in a wide format, which be more desirable for presentation purposes, rather than those being on a sequence, row by row. Of course, the other advantage is that reformatting the data, reshaping the data, allows us to perform some extra operations much more easily. In this particular situation, we're looking for the average life expectancy per year. All right? So this question is asking us about the life expectancy, not the population, and it's asking us to calculate that average life expectancy per year. So let's take a look at the second question. I'm going first to go and select country, year, and life expectancy. So that's a slice of the data frame here. And of course, we're interested in life expectancy, so we're not interested in country and year, we're only interested in life expectancy. But we're interested in doing this life expectancy over time. If we just calculate mean, what Pandas is going to do is going to calculate the mean of each one of these columns. Of course, year doesn't make sense to average year because it's an ordinal type. Life expectancy, it makes sense, but that's not what we're looking for. We're looking for this life expectancy broken by year. So knowing that the built-in function mean aggregate value calculates values averages over columns, then it's be possible to exploit the fact that we can arrange the data to use the built-in function mean. All right, so this will be very similar to what we have done above. We want to rearrange the data to have, instead of population, year over the columns, and then if we calculate mean, we can get the mean, the average life expectancy for each one of the years. Okay? So I suggest to pause the video and try to give it a try. Okay, so let's do the same transformation. What I'm going to do, I'm going to set index, country, year. That will give us the country and year. We have seen this, except that now we have life expectancy. And then I'm going to unstack year. That will give us the 2D, the white format version of that. And now once this is done, I call mean. And mean is going to operate on the columns, which basically boils down to calculate the life expectancy per year. So that's the average life expectancy per year, and you can see that it's increasing there has been improvements in life expectancy over time. All right? So just knowing how to use multi-level indexing allows us to reshape our data, but this opens up many opportunities for effectively analyzing this data down the road. All right, so let's take a look at the third question. And the third question is asking us about the average GDP per capita per continent. All right, so the first step is just to pay attention to the question. It seems that we're interested in two pieces of information, GDP per capita and continent. So what I'm going to do, I'm going to take a slice of the data containing GDP per capita and continent. Now this is my slice. And what I'm going to do, I'm going to basically apply the same transformation. I want to rearrange this data so that I have a continent on one of the axes, and GDP per capita is on the other one. So let's do set index, GDP per capita and continent, and see what we get. Now we have here the same data. What's interesting here to note is that we have 0 columns. Why? Because we use GDP per capita as part of the index. So we have no longer any columns in this data frame. This data frame contains just an index. So if we try to do something like this, unstack continent, we get nothing because there are no columns. And if we unstack GDP per capita, we also get nothing. We only get the continent. So what's going on? What's going on is that when we paid attention to the question GDP per capita and continent, we forgot to note that GDP per capita, each continent has multiple GDP per capita. And those GDP per capita values are changing over time. So the question doesn't say calculate the average GDP per capita per continent based on the yearly values, but that's implied. We have forgotten to include year in the slice of this data frame. We want the year because the year will sit on one axis and the continent will sit on another axis. All right, so let's do that. Let's do year and continent. And then I'm going to set index year and continent. Next, I want to unstack my data frame. Here again, I suggest you pause for a minute and think about how we want to unstack this data. So we want to call the function unstack, and we want to provide the level of the multi-level index that we want to use to unstack this data frame. Is it year or continent? If your answer is year, then this is incorrect. Although this is what we have done last time, it doesn't work here, because what we want to do in this situation, in this exercise, is that we want to get the averages over the continent rather than the years. In this particular example, this index doesn't work because there are duplicate entries in each one of the years for the continent. So for instance, there are many countries in a certain continent in the same year. So you will have the same year listed many times for the same continent, multiple entries for the same year, same continent. And Pandas here is objecting that, well, if you unshape it, unstack it, I don't know what to put in that cell, because simply speaking, we have many of these values, right? So the choice here of here was not wise in the sense that we needed another column that identifies the value, the certain value for the continent itself. Okay. So let's try country here. And we get the same issue because we have multiple values for the same country, the same continent, because the same country in the same continent may be listed many, many times in the data set. So it's not possible to uniquely identify the observation. So what do we do? Well, to nail down this observation, we need another um, piece of information, which is the year. I want to set my index to be country, year, continent. From a data perspective, this is the key that will uniquely identify the observation, which is GDP per capita in this case. All right. So that's kind of like the primary key of my observation. If I know the country, if I know the year, if I know the continent, it's possible to nail down GDP per capita. Well, of course, I don't need the continent here. I need country and year, but I need continent because I want to unstack this over the different columns. All right, so what we get here, we get our data frame unstacked. We can see that the index is country year, but most importantly, the columns themselves are continent. Right? Now, of course, in some of these years, for some of these continents, there will be missing values because those demographics data was not available for all countries in all years. But that's not an issue because when we calculate the mean, pandas by default will drop these missing values column-wise. So if I do mean, that shouldn't be an issue. Those missing values will be dropped and we will get the GDP per capita per continent. And these are the averages here, okay? And those numbers make sense. I mean, the order of GDP per capita, Africa being the lowest and Europe and Oceania being the highest, is what we identify as kind of valid observations. All right, so this concludes this exercise here. I hope you liked it. Stay tuned.